So here's what I'll try to describe, since we don't have time to do it, is the tests are done with chemical reagents. I'm sure most of you have had opportunity to do this sort of test before, but the kits that are checked out to certified monitors have all the equipment needed to test for air and water temperature, pH, conductivity, dissolved oxygen, and turbidity. This kit that I have here today, the turbidity test is done with a Secchi disc, but most of the waterways in our area are so shallow that a Secchi disc is rather useless. So there's something else that we've started using in some of the shallower streams and waterways. It's a turbidity tube. It has a little teeny Secchi disc down in the bottom of this tube that's about 1.5 meters tube, and you pour the water in and then look through the tube to use the Secchi disc at the bottom to let water out or add water to it until you can see the differentiation between the black and white quadrants on there. So those are the tests that this kit will do for you. I've worked with, well, this past school year I worked with over 6,600 school students in various environmental science programs, and a little bit more than half the students that I saw, we did some kind of water testing. Mostly we tested the water for dissolved oxygen. It was a great opportunity to take a group of students, walk to the creek, get a sample of water, talk to them about the field observations that monitors do, things that they can determine about the obvious health of the creek based on whether there's scum or debris on it, what the color of it is there any odor to it, those sorts of things, and then take our sample of water and go do a test for dissolved oxygen. The beauty of that test is it's a lot of steps, a ton of steps, lots of chemical reactions, lots of chances to follow scientific procedure, talk about safety issues. They put on their gloves, they put on their safety glasses. So it's a whole wide range of science things that you teach in the classroom about procedures, protocols that they get to hands-on do. It's a terrific little lab for them. So while they're doing the tests, some of the steps have some time involved in doing them. For example, when we're inverting the bottle, fixing the sample solution. So we talk about how does oxygen get into water? How does oxygen get out of water? Why would we care about the amount of oxygen in a waterway? What does it matter? What's at stake? So the kids get a chance to become engaged in finding out about a real place that's in their neighborhood and talk about some of the issues that adults who live in those neighborhoods are having to face right now. I don't know where all of you live. I live out in Montgomery County. Up till now, 100% of our drinking water has come from wells. But with that 2010 mandate, now within the next, year and a half, we have to be drinking 30% surface water. And so especially kids from out my way, when we're standing there at Spring Creek and they see how not clear the water is and low it is, and we talk about the fact that this segment of the creek is listed with TCEQ as impaired, and the impairment is bacteria, and the bacteria is primarily from dog poop, then the question begs, do you have a dog? Does it poop outside? Do you pick it up? Ooh. Well, if you don't like to think about picking up your dog's poop, how do you feel about drinking it? So there's always one kid in every class who says, well, wait, aren't they going to clean it up before we drink it? Okay, now he's asked the question that we want them to think about. Of course, the water's going to be treated before we drink it. Of course it is. But how expensive is that going to be when there are water quality issues with that waterway? Once again, I live in South Montgomery County. Up until February, my water bill was based on a rate of 75 cents per 1,000 gallons. In our March bill, they advised us that it was going up to $1.25 per 1,000 gallons. So a pretty hefty jump. But in addition to the actual rate for using the water, since about 8 months ago on my water bill, I've got this little $10 a month ding that's a SJRA pass-through fee. San Jacinto River Authority is the agency that's building all of that infrastructure to acquire, treat, and deliver that surface water. Well, about a month ago, a big article that came out in the local paper out there said that once that infrastructure is in place and that water is actually being pumped from Trinity River, San Jacinto River, Lake Conroe, and being delivered to our faucets, we could expect an increase, not a total, an increase of $3.68 per 1,000 gallons. So my water bill is going to quadruple overnight as soon as they turn on that tap. At the junior high and high school level, the kids who come and we talk about this, they get it. They understand. They may not be the ones in the family that pay the bill, but they understand the concept here, that how much that water costs is going to depend on how much treatment it has to go through before we can drink it. So then it's an opportunity to talk about, what are the kinds of things I could do? What could I do? Could I pick up my dog's poop? Oh yeah, they say. Well, what about my car? Could I keep my car maintained so there's no chemical dropping on the roadways that gets washed into the waterway? Yeah, they think I could do that. Could I conserve water by doing all those things, those top 10 ways to conserve water that are so ingrained that we don't even hear them anymore? They're out there and we don't even see them anymore, but maybe it's time for us to start seeing them and start doing them. Should we have been doing all of these things anyway? Well, yeah, we should. But now something is happening that's going to really affect all of our pocketbooks, and they get that concept. So while we're doing the test for dissolved oxygen, I can't even begin to tell you the kinds of questions kids ask. And I've done the dissolved oxygen test with these chemicals with students as young as 4th grade, and they are perfectly capable of grasping the concepts. But from 5th grade on up, they do great work. They really are engaged by all the chemical changes that they see. They're really enjoy, especially when we get to the end and we add the starch indicator and it turns blue and it's like, wow. And then we add the sulfate and it turns clear and it's like, oh. So it's fun for them. It helps them understand some concepts. It's a great way to reinforce scientific method, safety procedures, the whole ball of wax. And several teachers have come back to me to tell me, what a great experience their students have working with them. The teacher is the certified monitor, but the students work with them to go out and test their waterway. Sometimes I get asked, well, why do you need volunteers? Well, Clean Rivers program has X amount of funding and X amount of waterways to test. In Texas, we have over 191,000 miles of waterways. And in the Houston, Galveston, Lecton County region, I believe there are 3 professional monitors. So you can imagine they're busy all the time and can't keep up. They do well if they get to test 2 or 3 sites every quarter. So they need all the help they can get. In Texas right now, there are about 1,400 volunteer water quality monitors. Go out once a month to do the testing at their assigned site. Quite a few of the teachers out in this North Harris, South Montgomery County area are getting certified to test at waterways or even some drainage ditches that have a fairly steady flow of water that are near their school, so they can walk there with the students and take them out and get their water sample or do their testing. I want to tell you an example of one teacher that I certified. This has been about 3 years ago. 3 years ago. He was at a little private school over on the other side of the ship channel. Small group, small environmental science class. I think if I remember it was 11 students. And they'd only gone out twice to do their monthly water testing. Well, the third time they went out, they noticed there was kind of a bad odor in the air. So they decided to investigate. They went walking upstream in this little creek that ran on the edge of the school's campus property and found there was a little mom and pop water treatment plant there that was dumping raw sewage as part of their effluent. So they went back inside, called TCEQ. You know, I think there were some fines levied, but there was remediation done. Well, one of the things teachers tell me is that, especially by 6th, 7th, 8th grade, along in there, a lot of students begin to have trouble finding how science is relevant in their lives, in the real world. How am I going to need to know this? Well, I can tell you that those students found science very relevant in their lives. Now, after that incident, every time they go down to the creek, they take trash bags, they go do cleanup, they clean up all the way upstream and downstream from their testing site. They were very engaged for that entire year. They were seniors, so at the end of that year, they were gone, and the program continued with a new group the following year. But I mean, you know, that was a pretty powerful statement for them that science really had some relevance in their lives. So, since we don't have time to actually do the test, get water, and do samples, if you want to just see, why don't you show us the test for DO if you can find it, because that's the one that has the most steps in it. There we go. Yeah.
I don't know what's now.
Well, that's all right. I'll try to explain it. It doesn't have to.
As you can clearly see.
While we're waiting for this to load up. Yeah.
Are you given training in August?
Here's what I want to suggest to you all. I am more than willing to do a training for you if at least 6 or 8 of you or you and other teachers you know are willing to get together. I'm more than willing to do a training. You can contact Lisa. She and I have already talked. She will arrange dates and we'll coordinate, and we can do them here that you're familiar with. So if you're interested in doing this, just contact Lisa and we'll go from there. That doesn't look like it.
Could I ask you?
Yeah.
Why can we go to County Lines away from wells and the water service water?
No choice.
I mean, but why?
Okay, so it's a state mandate. The state mandated that the entire state has to be on 30% surface water by, I think it's the start of 2015. And then in another 6 or so years after that, we have to go to 60% surface water. And it's because, you know, we're using water from aquifers, and the populations in areas tend to be getting more and more dense, so that we're depleting the water out of the aquifers much faster than they can recharge, especially now that we are so far into this drought. You know, technically we've been in a drought since 1985, but these past few years it has reached such an extreme measure that there's not enough water to recharge those aquifers. So the state's answer was to go to drinking surface water as a supplement to those aquifer sources. Yeah.
I have a question on the training, because I'm really interested. How long is it?
Typically, we do phase 1 and phase 2 all in one long day. Start like 8:30 in the morning, go to 3:30 in the afternoon, and do phase 1, phase 2. Phase 3, your certification part is done at your waterway. I would go with you and you would do the test, and I would check out the waterway as well as your methods, your protocols at the site, and then certify you.
How
So,
long is the certification?
as long as you want to test.
Oh, okay, so it's not a yearly?
No, you don't have, we do ask certified monitors to come in about once a year for a quality assurance test. Just, you come in and quick show you, run through the test, but
Is there a cost?
no,
Even if the fall is free?
anytime.
Yeah, I'm happy to do it here.
Yeah.
If you want lunch, I'll have a turn fees, a couple lunch, but, yeah.
Yeah, we can do, test, training year round. Anytime we can arrange a date. And Lisa has graciously offered to let us do it here. I got you.
And the waterway can be a ditch?
Well, could be a drainage ditch, an actual numbered drainage ditch. Okay, all right, really ready now.
Dissolved oxygen is measured in milligrams per liter. Values less than 2 milligrams per liter are fatal to most species. Values less than 3 milligrams per liter are stressful to most species. And values greater than 5 are sufficient for most species. Sources of low dissolved oxygen might be high temperatures, excessive vegetation growth, which blocks out sunlight from the subsurface vegetation and leads to less sunlight, which leads to less photosynthesis, which leads to less oxygen. Then the subsurface vegetation dies, and while decomposing, it consumes oxygen. Another source might be high groundwater inflow. Groundwater tends to be low in dissolved oxygen due to reduced aeration. First step of testing for dissolved oxygen is known as fixing the sample. When fixing the sample, we will be using 2 water bottles, manganese sulfate, alkaline potassium iodide azide, sulfuric acid, a waste container, distilled water. Rinse the bottles and the caps twice using the sample water.
Great chance to talk to the kids about why are we gonna do it this specific way.
Then, fill both bottles with sample water. Insert the bottles into the bucket with the top down. While underwater, turn sideways and then right side up. Make sure all the bubbles come out and cap underwater. The goal here is to make sure you don't have any bubbles in the bottles. Pull the bottles out. Check for air bubbles. Then, put on your gloves and safety goggles. Uncap both of the bottles.
I usually show the little
Uncap the
skull and
manganese
crossbones
sulfate.
on the sulfuric acid to the kids
Make
first,
sure
to
it's
explain why
completely
they're
inverted.
here.
Add 8 drops to each bottle. Then, uncap the alkaline potassium iodide. Make sure it's completely inverted and add 8 drops to each bottle. There will be some spillage. That is why I've used these paper towels. Make sure you use a paper towel when you're in the field so you don't spill any chemicals in the watershed. At this point, we're going to cap both bottles and invert 25 times.
Again, it's another chance to talk to them about scientific
Allow the
procedure, why we're
precipitation to
doing it this way.
settle below the shoulders. You can see here the precipitate is settled below the shoulders. Now, we want to invert 10 more times.
Why are they inverting 10 more times?
Make sure it's well mixed.
It was well mixed at 25.
Then, once again, allow the
It's the
tip to settle
procedure.
below the shoulders. Now that the sample is settled below the shoulders, once again, we're going to uncap both bottles and add 8 drops of sulfuric acid. Again, make sure this bottle is completely inverted so that the drops are uniform. Then invert and re-invert both bottles for a minimum of 3 minutes. When we added the sulfuric acid, we saw material form known as flock, small specks that form in the solution. The goal with inverting for a minimum of 3 minutes is to make sure your solution looks like this, flock completely dissolved or significantly diminished. It may not always completely dissolve, but it will not affect the results. Once your solution looks like this, it is fixed and can be taken home and processed within 4 hours.
This is taken home and processed.
Well, because the next step is doing the titration. And so, you know, sometimes if it's raining or if it's a really hot day, you might want to just fix your solution there at your site and then go home to do your titration.
And they have a video of that.
Can you show us the titration? How we do our
Is there a DOE?
Yeah, it costs a whole bunch of money and they don't give them out to volunteers. So, we use them.
This works so well compared to a lot of those meetings.
And actually, they've done tests, side-by-side tests to see whether this is as accurate. And there's virtually no difference between this $10,000 probe and what you do with this. Yeah, we got 10 minutes, yeah. I think this is all
Hold
done.
on, this is titrating the sample. Titrating the sample, we will be using the 2 bottles of fixed solution, 2 vials, the titrator, pink cap, sodium thiosulfate, a starch indicator, a waste container, and distilled water. First, we want to rinse the vial and the cap of the vial using the solution. There's a small amount of this and roll it off the sides. Dispose of the rinse into the waste container. Then, fill the vial to the 20 milliliter line.
If you're familiar with it, this is a Winkler titration. Winkler.
Is this going to be good like a model?
Half the vial,
This is a Lamont kit. Yeah.
and add sodium thiosulfate with the pink top on the titrator. Insert it in sodium thiosulfate. Then completely invert the bottle. Turn the plunger out. Pull the plunger rate on 0. Expel any air bubbles that might form back into the bottle. Continue to fill the titrator until the top of the plunger rate rests in the 0 line. Then insert the titrator into the top of the bottle. Add 1 drop at a time, swirling after each drop. Goal here is to get it to a pale straw color.
I don't know if you heard him say the goal was to get it to a pale straw color.
which is another great chance to talk to the kids about the difference between a test that's subjective, that they're making the determination about.
Clearly see the difference in this shape as compared to the original solution. At this point, uncap the vial while leaving the titrator suspended over the vial so we don't lose any drops. Add 8 drops of the starch indicator, making sure the bottle is completely inverted. Place the cap back on the vial. Swirl. Again, add 1 drop at a time. Swirl. Until the solution is completely clear. Once the solution is completely clear, compare it to a white background. Make sure there is not a purplish tinge. Sometimes there is a little bit of purple in there, and you can't tell until you hold it against a white background. Then, read the value off the titrator, the nearest 0.1 milligrams per liter. Record on your data form on your first titration. Inject the remainder of the titrator into the bottle.
So, that is the really short version of doing the test for dissolved oxygen. For pH, it's also a chemical test for the vial. The conductivity, we use a meter for that, so we show how to calibrate the meter and then how to take the conductivity reading. In the kit, there's also a thermometer for air temperature, water temperature. So, yes, you could come to a training and learn how to do the tests and do them on your own without becoming certified, without having an assigned waterway, and without reporting in data. Yes, you may do that. But then you're on your own to get chemicals and a kit and figure out what to do with it. So the advantage, as I said earlier, to becoming a certified monitor is that not only does HGAC keep you supplied with the equipment and chemicals you need and support you may need, but when you're reporting that data in, your kids could track their data on the HGAC website for your waterway. I mean, you could involve them in other activities related to that data. And it really gives them a sense that they're part of some larger program. Yes?
How close do you need to be to your water supply so as not to have the DO change by just having it naturally dissipate?
Well, here's what we ask you to do. We ask you to test once a month at about the same time of month and at about the same time of day. And when you're doing it as a real test, I don't know if you noticed that he did 2 bottles of sample, did tests on each bottle, and then what you do is you average your answers. And if your answers are more than 0.5 apart, you have to repeat the test to be able to report the data in. If you want to engage students, and we encourage you to do that, it's always a good idea because there are a couple of subjective points along in there, like the color of the yellow. It's always a good idea to have the same students do that test for some period of time before you change. Say for that semester, these students do the pH, these students do the DO, so forth, so on. If I understood your question correctly, you have to, we hope the DO level stays more or less the same all the time when you test from month to month. But if it changes.
I think from the time of collection to the time of testing, for example, you're at a school where there really isn't a good place to
So you
test.
have to, well, then in that case, we'd encourage you to take your kit, go to the site, do the test at the site.
Well, but you gotta understand, if there's not a place close
Yeah.
for you to take your kids, there's gonna be a field trip involved.
Yeah.
That's not gonna happen.
Well,
So my question is, I live close to Lane Creek, and Bitter Creek, and places like that. Would that water be taken from there and brought 20 miles across Houston, and then the course comes 7th period, so have reason to.
okay, all right, here would be where the problems come in. Number one, it doesn't matter what temperature the water is when you collect it, the temperature is very likely to change. If it changes to getting warmer, that will affect your DO reading. If it changes to getting cooler, that probably won't change it, but it will possibly be different if you test there next time and it does get warm. There would be some logistics problems there. You know, we might have to talk separately about how we could resolve this.
Is that the biggest factor, is the temperature change?
Probably. For this test, that's probably the biggest factor. As liquids warm, they lose their ability to trap gases. So the water sitting, even if you get it in a bucket and take it back and let it sit inside the air-conditioned room, it's probably okay for a while, but even under those circumstances, it's going to change a little bit. So.
Could we keep it under some kind of a cooling system when we transport? Put it in the,
You know, well, here's what I'd say. I mean, really, if this becomes a point that's a real issue, is we could try it. We could go test at the creek and take some water, take it to the school, test it at the school, see what the difference is. Maybe do that a couple of times, 3 times, and if the difference is that significant, then we'd have to figure out plan B. But if the difference is not that significant, then, you know, maybe it's not an issue. Yep.
Isn't that the purpose of fixing that site? Because you said fixing.
Well, and that is the purpose, yes. That is the purpose of fixing it.
Fix doesn't matter if it changes temperature.
That's correct. But the fixing part is, you know, you're probably looking at maybe 25 minutes or so to get it fixed. We collect the sample, get it fixed. So, you know, if that can't be done, I don't know, maybe you could collect it and fix it at the site and then take it in and take the bucket of water in and do all the other tests in the class. I'm not sure of the time duration of the class. Anybody else have a question? Yeah?
Let's get to the result part. Is there a specific range that the results must be in?
No, there's a specific range that are indicators of the health of the water, but there's not a specific range that your tests have to result in. The answer is the answer. And over time, when you first start testing in a site, you're not going to know what those values are until you've done it for a few months. But over time, hopefully you'll build up a baseline of levels that serve so that if you go to test, you've been testing for 8 months and the answers are pretty much all the same, and then you go test and something either spikes up or drops down, then you know there's something to look at. I mean, we actually want you to get the same answers all the time for this.
I know you're talking about creeks and rivers, and I'm assuming you mean natural creeks and rivers. The closest thing I have to my campus is a neighborhood pond that, you know, would it be effective on neighborhood ponds?
No, it has to be flowing water, although it could be, as I said, there's a couple of schools that are next to drainage ditches that are, you know, stormwater drainage ditches. And so there's a couple of schools that are testing in those drainage ditches, but pond water would be a whole different thing, yes?
I just wanted to point out that it's really instructive for kids to test pond water just to see what DO is,
Yeah.
but you couldn't participate in this ranking of that.
Yeah.
So it's really still a good thing to do.
Anybody else questions? I'm running over my time. So please, give it consideration. If you think you'd like to know more, contact Lisa. We'll coordinate dates so that it works out for all of us to get together. We can either talk about it some more, or we can set a date, do phase 1, phase 2 training. At the end of that, if you're not interested in getting certified, you know, no harm, no foul. It still gives you some tools to use with students. If you are interested in getting certified, then you and I individually will go and do that. Yes?
So would the training take 1 day, or is that?
Training takes 1 day. Usually we do phase 1, phase 2 in 1 day, like 8:30 to 3:30 kind of a time frame. Thank you very much.